Unit 3, Video Lecture 5, Orbital Diagrams and Electron Configurations, Part 2. Once we become comfortable with filling in these orbital diagrams, we can create electron configurations without taking the time to construct complete orbital diagrams. And one way to do this is with the help of the diagonal rule. The diagonal rule is a memory device that helps us remember the order of filling the orbitals in lowest energy to highest energy. It helps us follow the Aufbau principle. The first step is to write energy levels from the top to the bottom. Then we write all the sublevels present in S, P, and D in F order. Remember, the first energy level only has the S sublevel. The second energy level has two sublevels, S and P. The third energy level has three sublevels, S, P, and D. The fourth energy level has four sublevels, S, P, D, and F. The fifth energy level has five sublevels. But notice this question mark. We're just sticking with the energy level number having the same number of sublevels. This isn't really important. 6 and 7. Again, remember, we don't need these. So, the last step, the reason this is called a diagonal rule is because we're going to start at the top and draw a diagonal line. Start drawing diagonal lines. So the 1s energy level is the first thing that we fill. We then come back up here and draw our next line through the 2s. Come back, and the next thing we would fill is 2p and 3s, 3p and 4s, 3d, 4p and 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, and 7p. Now, remember this 5g that said we didn't have to worry about? Because this is where we stop. This is the end of our periodic table, so we don't need to go any farther. Let's write the electron configuration for the following elements. Hydrogen has one electron. So following the diagonal rule, the first thing that we fill in is the 1s. So 1s, 1. We've placed the one electron, therefore we're done. Lithium has 3 electrons. So following our diagonal rule, we can fill the 1s with 2 electrons. Then we need to fill the 2s with just 1. We've placed 2 plus 1. We have 3 total electrons. So we're done. What about nitrogen? Nitrogen has 7 electrons. So we can fit 2 in the 1s sublevel, 2 in the 2s sublevel. So the next thing we need to fill is the 2p sublevel. So 1s2, 2s2, 2p3. This gives us a total of 7 electrons. Pause the video and try the electron configuration for nitrogen, potassium, zinc, and lead. They have 10 electrons. Potassium has 19 electrons. Zinc has 30 electrons. And lead has 82 electrons. We can use the periodic table to help us determine where orbitals are. If we look, this first block over here is called the S block. All of the S orbitals are in the first 2 groups of the periodic table. the groups along the far side, so the far left 6 groups are the P blocks. The middle section is the D block, and at the bottom we have our F block. These can help us determine the electron configurations of particular elements. Stop, go back. Along the bottom we have the F block. Knowing the location of the different blocks can help us determine the electron configuration of different elements. Let's say that we wanted to look at the electron configuration for carbon, which would be here. Well, we completely go through the S block. So carbon's electron configuration is 1s2 because we have two elements in the S block. To get to carbon, we need to go through the 2 elements in 2s. So it's 2s2. And carbon is the 1, 2 second element in the 2p block. So we can see 2p2. So that's the electron configuration for carbon. If we pick another element, let's say phosphorus, we can follow the same logic. We completely go through the 1s block. So phosphorus's electron configuration is 1s2. We go through the 2s block, 2s2. We go through all 6 of the elements in the 2p block, 2p6. The 2 elements in the 3s block, 3s2. And phosphorus is the first, second, it's the 3rd element in the 3p block. So its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p3. If we wanted to pick the electron configuration for iron, we completely go through the 1s block, so 1s2, through the 2s block, 2s2, all 6 elements in the 2p block, 2p6, 3s2, 3p6, 4s2, and notice we're in the 3d block. Remember that our Aufbau principle tells us that we need to fill energy levels from lowest to highest. So 4s is lower energy than 3d. So now we can come back to that 3D block, and iron is the 1, 2, 3, 4, 5, 6, 7, 8th element. So we have 3D8. There's the electron configuration for iron. Sometimes, as you saw with lead, the electron configurations can get pretty long. So we need a shorthand way to abbreviate long configurations. This shorthand notation is called noble gas configurations. We're going to make use of noble gases to help us come up with these. So what we're going to do is first find the noble gas that's closest to our element without going over the total number of electrons. We'll write that noble gas in brackets and then continue our electron configuration. So let's look. Chlorine. Longhand, chlorine's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. We can abbreviate the first 10 electrons with the noble gas neon, because this is the electron configuration for neon. So we replace these 3 with neon, and then continue the configuration. 3s2, 3p5. Let's look at another one. Let's look at some more. Potassium. Potassium has 19 electrons. The two noble gases, according to the periodic table, that are near potassium are argon, that has 18 electrons, and krypton, which has 36 electrons. Argon would be the closest noble gas without going over. So we would put argon in the brackets. Argon is at the end of energy level 3. So we would begin our configuration at 4s. We only need to place one more electron, so Ar 4s1. This is the noble gas configuration for potassium. If we look at bromine, bromine has 35 electrons. So again, our noble gases are either argon with 18 or krypton with 36. 18 still does not go over that 35. 36, krypton still has too many electrons. So we put argon in the brackets, pick up our configuration at 4s. Well, argon takes care of 18 electrons, so we need to start filling from there. So we can fit 2 in the s sublevel. So that's 20 electrons. We still need to place 15 more. After the 4s, we go to 3d. That can hold 10 electrons. So now we've placed 30. We only need to place 5 more. So after the 3d, we go to the 4p, and there we can place the last remaining 5. We've placed all 35 electrons. So our noble gas configuration for bromine is Ar 4s2, 3d10, 4p5. Phosphorus. You have 15 electrons. Our two noble gases that are closest are neon with 10 or argon with 18. Neon is the closest noble gas without going over, so we put it in the brackets. Neon takes care of our first 10 electrons. It's at the end of the second energy level. So we pick up our configuration with 3s. So we'll place 2 electrons here, 3s2. Move to our 3p sublevel, where we need to find a home of 3 electrons. So 3p3. Our noble gas configuration for phosphorus is neon 3s2, 3p5.